Yeah, so welcome everyone for Cloud Computing and Big Data for our lecture 9 today, Platform as a Service, which basically is a conceptual lecture connecting nicely to Infrastructure as a Service, which was really the baseline where you have components like networking, storage, computing, the essential services that you need, usually fueled up by virtualization. So virtualized resources, which helps you with resource utilization. So basically also with different users on different platforms, usually with this operating system benefits you have seen in one of the lectures before. The added value now from platform as a service on top usually comes in some form of components, some added value that basically several different people need in the cloud. And they often refer on that level to cloud developers. So people that have a, let's say, development lifecycle of some certain software, where they have to implement an app, like we have seen the Philips Hue, right? You have to have a good, proper app to really do all the lighting in your house. If this is terrible, people would not buy it. They will report it in the internet, and Philips would have large problems of actually using Hue because the app is a kind of key essential thing in it. You don't want to do manual switching of red and yellow and all of these different lights. On the other hand, for Philips, it matters for them that firstly, they never know how many people will really buy it. They can do some statistics and suddenly around Christmas, everybody is more into lights and there are peaks and people buying it more. So being prepared for the scalability is another key concern where the infrastructure is concerned with the physical resource scalability, that it's really there and available. The higher level is now making the software scalable, right? And that means that requests maybe coming in from HTTP will be channeled on different, let's say, devices automatically. Otherwise, you as a developer have to listen on a socket. When you know a little bit about TCP/IP and HTTP programming, you listen on a socket, then a request comes in, and then you have to work on this request in some function. What this gives you, it automatically will channel this from 20,000 users of different servers, making it scalable to execute your function, but you implement it in a way that it would be local, right? So that you don't think about this different scaling. Also, when I said about the databases, when you have a normal Oracle database or so that should scale to petabytes of data and you want to have the search in that very quickly, you have this Google search, big table, and then the Google search on top as a component, and you can really quickly make that happen. A normal Oracle database would take years basically to find that in this time. There's a question. Okay, there's a question in-house, a very good one. So the question arises to how the cloud providers really can give the capacity, right? Because when now everybody, of course, goes now online, the shops, let's say in COVID times, will be lots of all do their web shops. In the end, there need to be physical capacity. And actually, that's true. Of course, the hyperscaler, as we call them, like Amazon, Google, they are working with lots of over provisioning. They have lots of resources, let's say, always they're available, that they then give you also at some interesting spare prices. You will see the pricing here and there on these regions is very low. And when they're more used, then they increase the pricing. So in the end, however, they would have theoretical limits, right? Of course, when now everybody would go to Amazon tomorrow and everybody would migrate their solutions to Amazon, they would have a problem. When we come with a climate situation and say we want to have, let's say, a climate model running, they come to us in Jülich to run it on our, let's say, top #1 supercomputer, not to Amazon, because they cannot do that just on a day suddenly, right? They don't have the HPC device for it. But of course, their model is to really observe the customer needs over time, and they have lots of experience values in this. And basically, it's a segmented market. You will see in later lectures that there are different cloud providers, Uber Cloud, MS Azure, we already had, AWS. Chances are that the users anyway, not all go to one and will crack him. But of course, it's true. It's in a way, it's the scalability. I mean, it will end at some point in time, but they work with so much over provisioning, and they can do this because they have these large data centers where we talked in one of the lectures, lecture 4, the economics of scale, right? For them, it doesn't matter. If in a large data center, if they have a couple of rows more, it's cooled, it's connected, it's okay, basically from the energy. For them, that's not a big deal to do this. So that's why in theory, they always would have capacity enough. But of course, there kind of ends to this on the physical scale. Good question. Good, so let's come into the second part of the lecture to do a couple of more deep down ideas, what it means to do PAAS, basically. And again, a PAAS developer would be also not just, limited to this. They would also use infrastructures, and you will see sometimes you create an app, which is maybe in the Google app, but you still use the S3 interface from an AWS service, right? So this is also very important to understand that in a way, you're not really bound to just one cloud provider. If you want to have a good customer experience, you even should really consider doing different things. But yeah, so in the end, we talk about lots of things which you see here, which is more for the developers, right? So they have to think about this application lifecycle, always having, let's say, teams with new capabilities added to an existing game. Then this game should be not going to the market. It should be firstly tested, right? Once it's tested, it goes to some checks and then should become the major game outside. I think probably CCP Games here next door could have a very interesting say this, having probably like 10 different versions outside. Just one is the official one, and many others are just for A/B testing for different tests. And to keep that affordable and to do this is, of course, a very challenging business here. The cloud automatically has some benefits, like this geographically distributed development teams. In the end, it doesn't mean anything anymore, right? You don't have a server in the cellar with a Git structure or something. You can do this with a cloud. And usually all of these allow you to steer the number of users when you develop these components. So of course, here you have to pay the price again for it. But in the end, it's a really, let's say, ad hoc way of creating a very nice development environment where you don't care about many things, although you have to basically have, of course, the money for it here and there. Still, it enables, of course, for a startup, lots of opportunities at point zero without buying any hardware, without buying any, let's say, software developers that want to develop you a machine learning suite. You just use a machine learning suite that is existing there. And here's some different tools for this. Some of you know Eclipse as a development platform, perhaps from Java or so, or from basically IntelliJ, which is then also this kind of development environment with code highlighting and things like that. But this is just one part of the story, right? You have the whole life cycle, deploy, upload to the cloud, and then the testing strategy. We talked in one of the lectures already a bit about containers. You see the container registry with Docker. I will come to this also in one of the next lectures where we go into more detail. What is a container, what it entails. But today you see these development cycles are supported by containers a lot. So basically there, everything is inside for, really deploying that. And we will talk about more in this in lecture 12, where you really see they have the right versions of all the different, let's say, dependencies and libraries for you existing as well. So in a way, you would say you would do the coding in the cloud. And of course, here again, a kind of comparison that this is not just Google, the app engine or so. You will find several different services in one way or another, also in the different Amazon and MS Azure environments. Again, I just pick here the Google App Engine because I think it's quite good suited for that. And in previous time, it was even called Google Platform. Now they changed the name to Google Cloud, more or less. But in the end, they're very strong also from their kind of history where they come from, right? Because Google, the success story relies on the search strings and the search algorithms they had when Google was still a beta. And since then, they have their IT developed and actually optimized for this. And you see this in all the concepts we discussed with the Google Big Table, for instance, where they automatically from the beginning had to deal with search string search and analysis of, petabytes of data from all users around the world. And there where all the strength coming from. Good. So this is just a kind of notifying that, of course, here virtualization, all these concepts, all the different products are existing in the different, basically Google clouds and MS Azures and AWS, and you have even now actually special ones like described with Uber Cloud, for instance. Right here, just a short hint also again that, of course, deep learning to connect to our previous lectures is one of the key drivers in basically the cloud for big data. As we've seen, you really need big data and you need big processing. That's why you go to clouds. And the deep learning containers are now really, of course, for you again, very nice and easy. And again, we will talk more about this in lecture 12, because you remember we had all these different problems with the libraries and versions and so on. So the right version of Nickel with the right GPU, that is the underlying library, need to fit to the right version of TensorFlow or the right version of PyTorch. And then with the right version of Horowat, if you remember a little bit what also Rocco was saying, if you want to really scale out, to really use hundreds of GPUs in parallel in practice for real world and not, basically character analysis that we do here in the course. But the containers are very loaded, very powerful, and we will talk more about this. Around it, you see there already different, let's say, helper services you need all for that to use it. And this gives you another platform character. So you would say the container business is really one of the key aspects of the platform. That's why I spent also another lecture on it, right? That we cannot handle this all in one today in this course here. So we will pick the containers, and then you see the Kubernetes runtime that you need actually for scheduling all of these and to download them and to curate them with artifacts and so on, and how basically can very simply then have here a Kubernetes engine in the cloud. And the beauty is once it's containerized, you maybe can ship it as a developer also to Amazon, right? Because they can understand Docker images as well. So it helps you a little bit as developer to avoid the vendor lock, right? Or having just specific services in this specific Google Cloud. Once you are on this level on the container in the platform character, you a little bit help yourself of saying when now the price of Google Cloud's getting so high, I can relatively quickly move away to Amazon because they also have a Docker system available, or MS Azure. This is just a typical example for developers. And I would say today you find less and less companies that not use the advantage of basically containers in a professional environment, right? So this is very a set, let's say, at least in the business environment, a set approach to use this. And here another example of people how they're using the Google Cloud system. This is here the Dataproc service that we already know, basically MapReduce, Spark, and so on. And they combine this nicely with the BigQuery, which is then a data warehouse component. And again, I mean, the details are not so important here, but you see migrated on-premise Apache Hadoop to Google Cloud. So they could use their own MapReduce in-house, have realized it's too costly, too much maintenance, takes too long. I need the people. It's much better for basically for them to go just to the Google Cloud. There's everything hosted already, much easier. And now the size of a company like Vodafone and Twitter says it all on its own. When you now think about it, they run 226 models in parallel in production, right? For machine learning. They're not just analyzing once the data, they're constantly using your data to analyze and to do some profit out of it. And basically lots of these benefits that you see here, 600 on-premises Apache Hadoop services, they move to the cloud because, you have to think about what it costs now for Vodafone to basically buy all the hardware, get all the people done that on day-to-day business have 600 on-premise Hadoop servers, 600 maintenance, right? So security updates, operating system updates, library updates constantly. Then all the updates of the perhaps containerized solution that we've seen for deep learning. So Nickel updates on TensorFlow, PyTorch. So you have a whole workforce in this Vodafone and Twitter that basically would just work on this IT, which has nothing to do with Twitter itself or Vodafone itself. So just examples of the people that have used or use basically these services. And when you go to these websites, you will see many different stories from very many companies you already heard from, and they all use the cloud in one way or another, but they also nicely combine it. What I found when I look here and there and look if people have, changed their behavior every now and then, it's also insightful. For instance, is, Angry Birds, they're switching quite heavily here and there between the different providers as an example, which of course what you do, you compare prices, you see what possible better performance is in other cloud, basically in other cloud vendors. Now, when you come to this BigQuery, another use case application here from the Twitter channel, here is of course the sheer amount of information, and then in very quick time, again, what makes Twitter successful, but also what you have to provide. So here, the software development basically is key. And you see that the Twitter architecture to really deal with real-time tweets, right? And this is one of the reasons why there's a limit of 300 characters, right? Otherwise it wouldn't work. It's just very fast-paced information, and you have to process it very quickly. So that's why they're limited. But at least you see the whole blueprint of HDFS, again, a batch layer for dealing with all of this, and having a data flow with BigQuery, where you essentially have the scalability of these components so that Twitter don't care about these things, right? Twitter is his core business is somewhere else, of making the Twitter experience not really dependent on, implementing all of these components alone, but working on, the ad business and the different profile businesses, which makes basically the Twitter inherent code and all the other stuff dealing with scaling and so on. And especially you can imagine Twitter in several regions and so on, they suddenly have a big boost, right? When people with this influencers come into a tea shop, we have the interesting examples that, put an influencer in tea shop, suddenly have millions of people looking at this tea shop, never existing before in this particular regional infrastructure. So these influencers work particularly well for marketing purposes. And our best peak example where something is actually not really working out is having a massive peak in basically usage or retweeting and stuff like this. So implementing this all on your own is possible. In the end, it's also lines of code. These platforms, all lines of codes, all basically components are there. Of course, they're not open source, unfortunately. But basically you have similar ideas also in open source projects here and there. But the key comes really by, for a developer, I just use that as a Lego brick and I'm done. And think about that. This, of course, helps them to have the main components like Vodafone, Airbnb, we have discussed, Spotify, Twitter. They can concentrate on their market, basically what they are working on and not on the IT infrastructure. Now, Rovio games, having discussed this, they have quite an interesting journey. I use them here and there already as examples. They began as a very unsuccessful business. They had a soccer game which looked terrible and was a not success. And that's how you start as a small startup, right? So nobody knows you. Basically, you scale like nothing. You had 10 users in the beginning of the soccer game and it fails. So then they had an interesting idea of having some birds jumping, where everybody believed that this is highly not successful like the soccer game, right? There would be no movies about this. There would be no games about it, not million users or not many different apps. But however, here we see suddenly something totally strange, right? So these hopping birds somehow made it, right? And nobody could predict that at that time. Everybody was thinking it's a major hoax, these things. So here's a good example where you grow with your success in the cloud. Right. So when you do this now and have your small company, you have a couple of servers, you never know if, you need to scale the next day to many thousand users. If you go to the cloud, you can actually do this. And if you look inherent in these resources, and you see, I have not much yellow blocks on it because it also tend to change here and there. And the key for you is not to learn, that Rovio uses GRE, MemCache, but, if you want to have these successful applications and scaling of your time, you see that all of the major mainstream apps behind that, everywhere, they all use different components of the major cloud components of the major cloud providers, and always very different in nature from the architecture, right? So in a sense, this is the idea of the conceptual lecture today. Think about that when you now are in charge of this coming out of the course, and the guy said to you in the boss of the company, whatever, you have to develop an app for us. Then you don't do it on your own and don't do your own software development and stuff. You first look, what can the clouds provide me for the money we have? And then we will see what we need to build on top of it to make it really our app. Otherwise, chances are you fail and you will reinvest, money in the same things that others have already basically done for you. And I think this could be also explained by Rovio, right? This jumping, they could so much focus on this jumping of this interesting birds and all of this, because they didn't have to deal with the IT. IT was already there, right? Google was doing that for them. So in this sense, they could concentrate on creating new other funny birds, which are so successful today, and basically made it to the movies. And of course, they here and there then have large developer groups these days where they are very successful. Now it's a different story. Now they're rich. Now they can look, when Google doesn't provide me anymore with this service, I go to Amazon. Right? This is, of course, let's say something which comes over time. But still here and there are good components like here this MemCache, which is one where you really use significantly the kind of the memory that is available on machines to have cached user requests again and again used, which is of course in these kind of levels, when you talk about games, always the same case, right? Because you have always HTTP requests to get basically your app data over. And of course, there are many requests are very similar in nature or very typical in kind. Let's say you have the same enemy or the same angry bird flying around there. You always would have basically the same properties from a database queried. And this is then maybe already in cache and makes it very quick as well. It's just a tuning component, tuning platform component, but it makes such a big difference for app design play, so to speak, that if that would be not existing, maybe Angry Birds would not really fly because it would be too slow and nobody would really like it. And there are very, let's say, many of these different components. They also actually in their review looked at the users API is very nice. So there's another story for them to really use them. And of course, in a course like this, we cannot do all the different details just to get conceptually the different areas. And another area is really NLP, natural language processing. So there, the field basically is also very far in providing already all the components you need for it. You see here, speech to text, auto-ML techniques with text to speech, speech to text, the way around it, translation, all of these elements where you basically should never really do yourself coding. You just think about if you need something for Chinese, you use a component for that and it will translate your whole app to Chinese. Right? For Iceland, that's a tricky question. Actually, my colleague Hafstein can tell you a little bit more about it. He is an NLP expert. But of course, because Iceland has not a rich corpora, here it's a bit difficult to do. But in the end, and you know that when you do Google Translate, sometimes you have very funny elements. I don't know if the guests here in the country have realized that. So sometimes there are very interesting translations coming, which you not should trust by heart, actually. And yeah, so you basically can there, have hell a lot of services in all the different, clouds. And I hope the Icelanders can confirm. Have you tried Google Translate for Iceland? It's not nice, right? So, but actually in other languages where the corpora is more, where let's say more is in terms of analysis possible, that is actually getting quite good. And of course, you just can use this also to tweak and then to modify and advance on these systems, right? Nobody says that by using them, you cannot further train the NLP system, but many of them are pre-trained. Of course, you go on, think about businesses, annotation services, apps that can provide you particular golfing scenarios. I just heard today something about horse riding app that can track like a runner where you are with a horse and all this different information, which is tons of information about it. So if you do this, essentially you have image recognition, you have basically the tracking of GPS, positioning, all of these are all components you can combine as a developer. So there's no need to create that basically totally from scratch again. And if I know we had started in the beginning with Iris setosa, Iris virginica, if you remember. So if you have this app to program, all of these components to actually do this and have a photo in the field and make a picture of it and analyze it with machine learning, is it an Iris setosa, Iris virginica, would be just components you combine from this set that you basically have in this different clouds available. And this goes now, you see all the different sectors where basically people use it. You can imagine there's almost no category of service which is not in the cloud these days, handle, different elements of, basically video analysis, image analysis, and things like that. Right, so, and we talk more about this in containers and so on. Then the Tensor processing unit, I basically have tried this already. It's a bit old school these days. I would say it was basically one approach of Google to have a very specific circuit, essentially, which is a tensor processing unit optimized for tensors. Tensors, if you remember, are this multidimensional arrays that we have also used in lectures 6 and 7 for our deep learning networks again and again. But the test of time is that NVIDIA is just so strong and have created their own TPUs. If you look in a GPU today, these are tensor oriented and tensor processing units in a way. So the advantage of this Google Cloud TPU is not really anymore there. But just for you to understand, it essentially was very optimized on deep learning. And the idea was probably to sell it once, but they never did. So basically the TPU existing in this cloud is there. Some other services and programming models MapReduce have covered. I could go on and go on. It would fill another complete course using all the open source tools from Apache with, Hadoop and MapReduce. But this is something, of course, where all for this components where can freely choose, and no matter where you are in the cloud, they have something similar in this area existing for your data processing and your analysis. Of course, with this comes some disadvantages because they're not really standards. And this is an example just that you heard about it. Of course, standardization is a key problem in cloud computing because there are many vendors and less standards. And here's one, let's say, web page that, at some point in time really tried to standardize several things called, cloud platform from Manjrasoft. But also this was not really highly successful these days because the vendors are so powerful. They can do what they want with the services. They change often, change the APIs. One example, which might be something like a standard de facto standard, is something like the Amazon S3 interface. This is something you can count a little bit on. You can remember Gradescope is using it, for instance, but standardization is really a very hard topic in cloud computing. However, once you use these components, of course, you're really on steroids and can scale and have lots of different advantages. So I tried to summarize this in 3 minutes. And for those of you that maybe have other classes or so, again, feel free, to leave. This is more or less a summary of all the benefits of the platform as a service. And we continue on Thursday, then with lecture 10 with, software as a service going one level up again.
Lingo, speak like chaff. It's the perfect place to learn what these strange business buzzwords mean. And I'm the perfect person to explain it all to you. I've been an entrepreneur for longer than I care to remember, and I've made the decision to share all my insider knowledge with you. In this series, I'll put into plain English what these seemingly confusing business terms mean. Today, we're going to look at PAAS. Okay, I'll forgive you if you immediately think of a football team playing the beautiful game and linking up a series of quick, accurate passes before scoring a wonder goal. As much as I love watching a team sweep forward, we're talking about a different type of PAAS. We're more concerned about platform as a service. If that seems like gobbledygook, let me explain. You'll know that nowadays, we depend on the cloud for everything. The cloud is short for cloud computing, which simply means that data is stored and accessed through internet programs instead of your computer's hard drive. PAAS is a cloud platform service that provides cloud components to certain software while being mainly used for applications. Essentially, PAAS lets developers build and create customized apps. Servers and storage can be managed by third-party providers while the developers can manage the apps. Still confused? Let's go back in time, way back in time. I'm not even talking about pre-internet times, I'm talking prehistoric times. This is Rab the Rockstar. He had the vision and belief to set up his own business at a time when his pals were more worried about surviving the winter. Rab couldn't hunt to save his life, literally, but he started designing and making tools for the most successful hunters in the village. He turned sticks and stones into spears and used mammoth tusks to make bows and arrows. Obviously, Rab's business didn't benefit from the internet. But if the internet had been around, he could have used PAAS to help run his business. He would have needed to sign up to a PAAS platform like Windows Azure, Amazon Web Services, or Google Cloud Platform. And then he could have worked with the developers to build customized apps. Say one of his clients wanted to order more spears and they wanted them delivered the following week. Easy, just use the app that would have been specially designed for Rab. And the best bit is, Rab wouldn't have had to worry about operating systems, software updates, storage or hard drives, as this would have all been taken care of for him. Back to life as we know it, and there's lots of advantages for businesses who use PAAS. Developing the app is far cheaper, it's scalable, the apps can grow and change as your business grows without causing you a lot of hassle, and lots of your colleagues or employees can use the same development application. Web services and databases are all integrated, making sure everything runs smoothly. So there you go, Speak Like Chaff has explained another confusing term you need to know when it comes to running your own business. Pass it on, or should I say, pass it on. And don't forget to hit the subscribe button, and you can keep up to date with my business advice on my YouTube channel. It's completely free and could change your life.
All right, okay, so that's all for today. And the next time we have basically software as a service as the next topic, going again one level up.